So in this session, we are going to study a new concept which is recently added in C programming language, that is called as file handling. Okay, so we'll start with what are files, why do we need files, why do we need to use files in programming, and so on. So why do we need a file, and what is a file? A file can be used to store data and information, right? All these files that we have, for example, your Word file, it is a type of file. Then you have your normal document. For example, let me show you some files. So this is your Word type of file. Okay. How can you identify this is a Word file? You can write some data, you can have images in this file, you can have certain links in this file. Then you can have certain diagrams, you can insert certain shapes and all. Okay. So what can be done in a file? You can organize your data well, or you can present it well, or you can store some data in a file. Okay. This is one type of file which the extension is .doc. If the extension is .doc, then it is a Word type of file. Then we have the text files, in which basically you only type some things. Usually you cannot store images and links and all that, right? So this is a text file. That is because you can only have text in this, only sentences, words, paragraphs. And the extension is .txt because it is a text file. Then another type of file which you are seeing on my screen for the presentation is the PPTs, that is with the extension .ppt or sometimes .pptx. Then you have Excel files in which you can organize your data in the form of cells, or you have rows and columns. For example, the extensions are one or more for Excel files, maybe .xls or .exl sometimes. Here you can have the data in rows and columns. You can edit a particular row or a particular column. So you have different types of files. Another type of file is binary file. In binary file, as the name suggests, the data that you store will be in the binary format of zeros and ones. Right? So binary files have a sort of security, because directly if humans go to read the binary file, they'll only see zeros or ones or some weird characters. Means they cannot understand what is written in the file. But if it is a text file, that is the normal text file, some sentences can be read easily, right? So these are the different file formats. Okay, and normally that files that we use in C language are the text files and binary files. Okay, these are the types of files which I've shown you in brief. Now files are used to store data and information. Now there is a difference between data and information. These two terms are not the same. The difference is, in terms of computer science, data is nothing but a set of facts, some statistical data or statistics, uh, okay, or some ratios. Then you can also have certain characters, certain characters on your keyboard. All those characters can be written. Then you can have certain numbers, alphabets, anything. Means a collection of facts, characters, statistics, or anything on your keyboard. A collection of anything on your keyboard characters will form data. Means it was raw data. It is considered as unprocessed data, or you can say raw material. Once you refine your data, or once you structure your data, or once you grab only the required part of your data, once you refine your data, then that refined or processed data becomes your information. Means you can easily draw certain conclusions from information, but you cannot draw certain conclusions from data. For example, if you want to know, in a shop, the shop is selling certain items or certain books, clothes, whatever. So you want to know how many books have been sold for one day, or how many shirts are remaining in the shop, right? You want to draw certain insights, you want to conclude something, you want to know something. Then if you have data, then you will not be able to understand properly, but if you have information, you will be able to understand. So what is an example of data for this scenario? In data, you will store maybe customer's name, then you may store how much money he has spent, then maybe his address and all that. But to know that how many shirts have been sold, You do not need the customer's name and all, right? You just need to know how many shirts have been sold. What is the count of the shirts that have been sold? So if you have so much raw information, you will not be able to extract what you require. That is what is data. You have unnecessary information also, you can say in that way. Okay, means it is a collection of unprocessed or unrefined data. Once you refine it, maybe in a tabular form or maybe in simple sentences, once you refine whatever you require, then it becomes information and you can easily extract what you want from your information, right? So this is the difference between data and information. Data is nothing but raw material. Once you process that, you get your information. Okay, this is the basic difference. Not so important, but I just felt like telling you. Now files can be used to store the data permanently. Okay, so as I've mentioned already before, what do you do in programming? You run a particular program. Okay, first what you do, you create a new file in your IDE or wherever. Then you write certain code in your file. Then you save your file. Then you compile your file. Then it file is suitable so that you can run it or execute it. And then you'll get certain output. Then you suppose you close your program, you close your output window, everything is shut down. You shut down your machine as well. Then after some hours or maybe just after you shut it down, again you start your machine. Then will you be able to access the output of that program? No, right? Whatever you close down, it is lost forever. You cannot access it again. So this was one disadvantage. For example, suppose you have created a record for students, like how we did in an array of structures. We created a student database where we stored the name of the student, his class and division, roll number, and all that. And then we inserted some items in our student database. Suppose we inserted the details of roll number 1, 2, 3, 4. Okay. Then I had some urgent work. So I shut down my machine. I did my work. I came back to my machine, started it. But then what do I see? Whatever I had stored for the roll number 1, 2, 3, 4, that has been erased. So what I'll have to do? Again, I'll have to store all the details. So there is no permanent storage. How will you access the previously stored data? So to solve all these problems, to store the data permanently so that it can be used in future again, you have to use the concept of files. So what you'll do in files, whatever output of your program you get, you can write it or copy it to a file. And then you will shut down your machine. And then afterwards, you will start your machine again. And whatever is in the file, you can access it. What is in the file? The output of the program. So your data is not lost. Once you access the data from your file, whatever you access, you can write it back to your program so that you can use it in your program, right? So you can access your data through files. You can store your data permanently through files, not through your normal programs. Programming is just, you can say, at the moment or temporary process. But if you want to make it permanent output, you want to store it, then you have to use the concept of files. So let us get back to the presentation. So you can read and access the data from the file, right? And one more thing is why your program output is not stored, but why the files are stored, right? So let us answer this question. So you need to have a certain background of your organization of and architecture of your computer. What happens? Whenever you write a program, it will be compiled and an executable file. That means your higher level language has been converted to binary language, zeros and ones, which the computer can understand and process, which the computer can work on. So whatever you have compiled, that particular file is, okay, let me show you an example. See here, I have this program called as type checking. Okay, I can click on this program, it will open up. Now, once I compile this file, what is this you can see? Till now, you might have observed by now that another file with the same name has been created, right? But what is the change between these two files is the extension. This is a .c file and this is a .exe file. .exe means it is an executable file. Whatever the compiler does on your file, the output of the compiler is also a program which is applied to your program. Compiler is a program or a system software that has been applied to your user defined program. So the compiler will compile your program, and whatever is the output of the compiler, that will be stored in a file with the extension .exe. So .exe file is nothing but the output of the compiler. Whatever the compiler has done, that is stored in this file. If I open this file, Just a minute. Right, so it is opening the .exe file. Just a minute. So it was opening a .exe file, means whatever the compiler has compiled, right? So now you have understood that you have the executable file. Now this compiled file, that is the executable file, as well as your program file, both those files will be stored permanently, right? Because once you shut down your machine, again you start your machine, your program is there in your IDE, right? You don't have to retype your program, it is there. So your program will be saved. It will be present even after you shut down and start again. But the output of your program is not getting saved. Means what? Your program file is getting stored in some other location and the output will be in some other location which cannot be stored. So basically, there are two parts. Okay, let me draw a diagram to show you. There are two types of memory in a broad sense. There are two types of memory. One is volatile and one is non-volatile. Or you can say one is RAM and one is which is your primary main memory, RAM, which is volatile or which is temporary memory, you can say. Another thing is ROM or your secondary storage devices like your hard disk, USB, CD, floppy disk, all that is ROM. That means that memory is permanent. So whatever is stored in ROM, that can be stored permanently. Only you can delete whatever is stored on ROM. Suppose you have a file X over here, then you shut down and start again, it will remain in your ROM. It will be accessible. But you can delete this file, right? If I want, I can delete this file. I can simply click on options and delete it, right? And it will get deleted. So you have erased it from your secondary storage or from your ROM. Okay, you can do it. But if you do not do it, it will remain permanently, right? But RAM is how, suppose you have written the output, you have got the output of your program and your program is now in the RAM memory. Then once you shut down, this whatever is there in the output or whatever file is there in your RAM, that will not be stored permanently. It will vanish away, it will disappear. So again, you'll have to prepare this file if it is in RAM. That is why whatever files you create, they are by default in your ROM so that you can access them in future. And if you want, you can delete it. But RAM, whatever is in the RAM, once you shut down your machine, it will go away on its own and you have to cannot recover it. Okay. So what happens whenever you write a file and when you save it, it will go by default in your ROM or in your permanent memory and you can access it in future. But when you want to run your program or when you are working on your program file, it will be loaded in the RAM. Okay, whatever is on the ROM has to be copied to the RAM. It will get executed in the RAM, whatever output you will get, and then you'll close your program. That memory will be released. Okay, RAM memory will be released. So I repeat all these statements that I've said till now to summarize it. You have certain permanent memory, ROM, and you have temporary memory, suppose RAM. Okay, I have written my program and I have saved it over here in my RAM. Okay, so when I want to run this program, what will happen internally? This program file will get copied to the RAM memory. So now my program is in my program file, the code is in my RAM. Now I am able to execute it. You can execute it from the RAM only because RAM is a fast memory. If you go to execute it from ROM, it will take a lot of time. It is very time consuming and you can say almost impossible. So only the program, whichever you are working upon, temporarily, it will be brought to the RAM. You can execute it from the RAM. And then once you close your program, the memory allocated over here in the RAM will be released. So the program will not be in my RAM now. It will only be in my ROM. Okay, have you understood how the programs are run?
Yes.
Yes.
Okay, so this happens for every file, not only your programs. Even if I open Word now, I'm working on this Word file. So it has been loaded or copied from my secondary memory, that is permanent memory, to my main memory or ROM, main memory or RAM, primary memory, RAM, main memory, all is same thing. Now I'll write something. I want to save this. So when I save, it will go to my secondary memory. I will close this file. Then again, when I want to work on it, it will be loaded in my RAM and then I can do any editing if I want and again close it, again it will be released and it will be there in the updated form in my ROM. So this way for each file it will happen. Just a minute. So we have seen that how the programs are run. So now we can say that files are stored permanently. So whatever file you create in your C program, it will be stored in permanent memory. Similarly, to store the output, you need another file, which may be a text file or a binary file. And that file will be stored on your secondary memory, permanent memory. And whenever you want to access, you can access it just like any other file. So now let us get back to the file handling concepts. So files make it easier for the program to access and store the content without losing it upon the termination of your program. Once your program ends, you will not lose the data. Okay. So as I said, volatile and non-volatile memory. Volatile memory is the computer storage that maintains the data only when the device is powered or when the device is on or when the device is working. Only that time the volatile memory comes into picture. Once the device you turn off the power or shut it down, whatever was in the volatile memory that will get disappeared forever. You cannot recover it. Okay, so and one more thing, your volatile memory is limited. Okay, so sometimes when you open many files or if you're working on many files simultaneously, your device gets hang, right? It will hang, your device will hang. Why? Because your RAM is not able to handle so many things because RAM memory is volatile and limited. For example, your RAM is whatever memory is available for your RAM is always lesser than how much ever is there for ROM or your permanent memory. Right? So many files, so many folders you store on your desktop where it is stored on your secondary storage or RAM or ROM. Okay, secondary storage, on that you are storing your files. So only you are able to store so many files. Okay, but when you want to work on them one by one, they will be loaded in the RAM and you can work on them. But if you open so many files and are working simultaneously on so many things, since RAM is less, you cannot work efficiently on all of them. Your device will become slow. Okay, so volatile memory is less compared to non-volatile memory. So RAM will hold the data, programs, and information as long as there is power supply to your device. And if it is interrupted, like suppose the light goes off in between, the MACB light or electricity supply goes off, then suppose you don't have an UPS, then your computer will shut down. So whatever was there you're working on, if it is not saved, then you'll have to again do it from the beginning. But suppose you had saved it and then the lights have gone, then it will be saved and you can start from where you had left, right? Because it had gone in the permanent memory. When you save it, it goes in the permanent memory. If you do not save it, it remains in your primary memory or erasable memory. Now this type of memory, that is non-volatile memory, is also called as permanent, and you can store it even if there is no power to your device. It will be retained or it will remain over there. Now volatile memory will hold data temporarily, and it is limited, and it is used for long-term storage. Which one? Non-volatile. Okay, so these are basic differences. Volatile memory is less, non-volatile is more. Volatile memory is temporary, non-volatile is for permanent storage, and it gets deleted on its own in volatile memory. But in non-volatile memory, if you want, then only you can delete, otherwise it will not get deleted. So example is RAM memory for volatile. For non-volatile, what are the examples? Hard disk, compact disk or CD, floppy disk, USB or universal serial bus, and then your magnetic tapes. So files are stored in non-volatile memory whenever you save them. Why do we need files? As I said, if your program is terminated, data is lost because it is in the RAM. So storing a file will preserve your data even after the program is over or terminated. RAM is not able to handle large amount of data. That is why I said it is limited memory due to its small size compared to the hard disk. right? Hard disk size is always bigger than your RAM. So it is easy to transfer data also as files. If you want to transfer data, it is easier through files. Now, types of files that you usually use with your C programs, that is which type of files the C programs can access: binary files in which the content is in the form of zeros and ones, or text files in which the content is in the form of words, sentences, letters, paragraphs. Now, binary files are what? The files in which you store data in the form of 0 and 1. They are not directly readable, right? It is not possible for us to read zeros and ones directly. So an application or software is required, extra additional application, so that you can read these binary files. An example, and your C programs can read the binary files on their own, right? Why? Because computer can understand zeros and ones, so automatically the computer will be able to understand the text in the files, which is in the form of zeros and ones. If there is a text in the form of English letters or sentences, the computer has to first convert it into zeros and ones, and then only it can understand. Anything which you store on your computer, it has to be converted into zeros and ones, and then only the computer will be able to understand it. Example of binary file is a doc file. Okay. Now text files, they can store data in the simple text format. They are directly readable, just like how you can see here. I've written types of files. There are two types of files. You can directly read it. Same is the case with text files. No software additionally is required. You can directly read it. Example is .txt file. That is your notepad files. Okay. By notepad, you can create your .txt files. Next, you can perform certain operations on these files. Now, what might be the operations? See, first you want to create a file, then you will write something to that file, then you will read something from that file, and then you will use whatever you have read. So basic operations are: you will create a file. After creating, you cannot directly read or write to that file. What you have to do after creating the file, first open that file. Okay. Then you can read whatever is written in that file, or maybe you want to write something and store in that file. Okay, you have done certain operation. After that, what you'll have to do, you will have to close the file. Okay, automatically the file will not get closed. This is when you're dealing with files in programming. You can access the files through your C programs. Okay, that time you have to do all these operations. When you want to access a file in your program, what you have to do, you have to create a file, open a file, read or write to a file, then close a file. Okay, so we will be seeing all these operations now one by one. Okay, so how you will create a file using a program. See, basically how I create my file, let me show you here. Suppose I want to create a file on my desktop. Then what I'll do, I can go to new, then whichever type of file I want. Suppose I want to create a text file. I will select this one. Then I can give the name of the file, suppose program file. Okay. So I didn't do much work, right? What I did, I simply selected new and the type of file, and I created the file. Now I can write to this file, I can do whatever. Okay, but this same task which I did just now, that is creating a file, you can do it through your C programming, right? You can create a file, whatever I did just now. I selected new, selected the file type, and created it. But this same thing you can do through your programs also, and very easily. Okay, so that we'll be seeing now, how to create a file using your C programs. So the rules to be followed is, while working with files in C programming, you have to declare a pointer of the type file. Okay, what you have to do, you have to create a pointer which points to a file. Now, just like how we had array, structure, these are the derived data types or user defined data types, right? Array is what? Derived data type. Structure is what? User defined. So these are, file is also a type of data structure. Okay, it is a data structure called as file structure. So you can create a pointer to the file. Okay, and using this pointer, you can do different operations on your file. Using the pointer, you can open the file. Using the pointer, you can create the file. Using this pointer, you can write to your file. Using this pointer, you can read your file. And using this pointer, you can close your file. Okay, basically these operations we can perform. So how you will create a pointer to a file? How do you create a pointer to an integer? You write int a. Suppose this is an integer. How you will create a pointer to this? You will write int asterisk ptr, suppose is the name of the pointer variable, equal to ampersand a. So what you have done, you have, how can you create a pointer to an integer? You can create a pointer to an integer by writing int star ptr. Similarly, how you can create a pointer to a file? You must write in capital, okay, uppercase, file asterisk ptr. Okay, this way you can create a pointer to a file, and you can initialize it to null initially. So this is the similarity. If you want to create a pointer to an integer, int star ptr. If you want to create a pointer to a file, file star ptr. Okay, for example, I have written the same thing, file star ptr, and initially you should initialize it to null. Okay, this is a good practice, so that by mistake, if you have not initialized it to anything, and if you want to print the value of this ptr, then it will print randomly some value to whichever random address it is pointing. But if you initialize it to null, then what will happen? It will print out 0. It is safe. It will be safe. Okay, it is a good practice. So now let us see how can we create a file. Now, if a file is already existing, you don't have to create it. You can simply open it, right? If a file is already existing, simply open the file. But if the file is not existing, first create the file and then open the file. So the syntax is you have to use the fopen function. Okay, this is a built-in function, just like your printf scanf. This is a fopen function. So the value assigned to the pointer will be this function call. So whatever value is returned by this function will be the value assigned to ptr. Okay, and what will be it? It will be an address. So when I write file star ptr, if you want to use a particular file, you must write equal to fopen and then something within the bracket you have to pass. Okay, so this is the basic syntax. If you want to access a file through your program, this is the syntax, file asterisk ptr equal to fopen, and within the parenthesis, you must pass the name of the file along with certain mode. Okay, we'll be seeing that in detail now. So have you understood till now how you can use files, why you need files and all that? Have you understood?
Yes.
Yes.
Yeah, very good. So now we will create a file and open a file. And whenever you open a file, you must close a file. Okay, so I'll show it to you directly in a program so that you understand properly. And you don't have to include any header files for file handling concepts. You have to simply use stdio.h only. You don't have any separate header file for file handling. Okay. Then you can have void main. Execution always starts from main. Now I will create a file. Okay, I will create. Till now I don't have any file. I will create a file. So before creating, let me show you one directory in my laptop. So at the moment in this directory, there is a single PPT file. Okay, there's only a PPT. There is nothing else. Okay. Now, once I execute this program, a file will be created here automatically. Right? That is what we want to do. If I want to do it manually, what I'll do? I'll go to new. I'll create a text file over here. I will name that file and over. I have created a file. Right? I can access it. But the same thing I will do through a program now. So initially there is nothing over here except this PPT file. Okay, there can be no file also, it's okay. Even if you have files, if you don't have files, it's okay. So now what I will do, I'll write in uppercase file. Okay, let me show it to you simultaneously so that you don't miss out on anything. Okay, file asterisk ptr equal to fopen. Within my brackets, I must give the name of the file within my double quotes. And suppose the name of my file is my file. Okay, this is the name of my file, my file. You can name it anything. Okay, and you must specify the type of this file. It is a text file, so I'll write .txt as the extension so that the compiler understands. I'll give comma, and there is a particular mode, means in which form you want to create this file or in which form you want to open this file. See, this function, suppose the file was already existing, I had to just open it, but now the file is not existing. So first I'll create it and open it, but in which mode I will open it, right? If you want to write to a file, you have to open it in the write mode. If you want to read a file only, that means you want to know what you have stored in the file, you want to read the content of the file, then you have to open it in read mode. Okay, there are different modes other than read or write. For now I want to suppose read the content of the file. Okay, there is nothing in my file, so whatever I read will be empty. Or let me open it in write mode, means there is nothing in my file, so I want to write something to my file. Okay, so I have written file asterisk ptr f open, the name of the file with the extension, comma, the mode in which I want to open. And then you have to close your file also. For closing a file, the syntax is fclose function and pass the file pointer to it. So the syntax is fclose and then brackets. Within the brackets, you have to pass the pointer variable name, ptr. You can call this fptr, a, b, c, whatever. I've called it ptr. Okay, now I have to save this program file. Okay, I have to save this program file. So I will save it. Where I'm going to save it? The directory which I just now showed you. That is this one. I will save it as, you can save it as anything, no issues. File handling demo, program 1. Save it as a C file and save. Okay, so now what all is in my directory? The program file which I just now created. Okay, it is not the file, actual file which should get created. My file is not yet created. Why? Because I've not yet run this program, right? I've not yet ran this program. I've not yet executed this program. So only the program file is saved. Now I have to run this program and then the myfile.txt file will get created. So let me run this program. I have run it, executed it. And as you could see, immediately what happened? One thing what happened is the executable file, that is the output of the compiler, has been created because I executed my program. And then what was in my program? I had to create a file. So that file has got created, right? Automatically. I did not create this my file. This is your normal text file which was created through your program, right? Have you understood how I created this file?
Yes.
Yes.
And one more thing, where you store your program, there only the file will get created in that same folder, right? If you want to create it in some other location, then you have to specify the entire address of that location. Like if you want to store in D drive, then D:// whatever this this comes, no, C:/ users name desktop. You have to specify this whole address and then you can store it over there. Okay, that we'll see next time. So basically now what we have done, we have created a file in the same folder where we saved our program file, okay, through programming. Okay, so I think we can stop here for today. Any doubts you can ask me and put your attendance in the chat box. So file handling concept is very important and interesting, and it is simple also to understand, but you must pay attention. Okay, any doubts? If you put your attendance, you can leave this. Thank you.
Thank you.
Welcome.
Thank
Welcome.
Thank you.
Welcome.
Thank you.
Welcome.